We would like to begin by acknowledging that this presentation is being broadcasted from Surrey, British Columbia, Canada, on the traditional and unceded territories of the Coast Salish peoples. For more information, please visit the website link on the slide at native-land.ca. I will now hand it off to Sophie to talk a little bit about SRIL and our sponsors.
Thank you so much, Clement. Hi, everyone. My name is Sophie, and I am SRIL Robotic Innovation Lab's president and founder. Thank you so much for joining us today. And on behalf of the entire SRIL Robotics Innovation Lab team, I would like to welcome everyone. Thank you so much for spending your Saturday afternoon with us. And we're excited to teach you about computer-aided design, as well as give you the opportunity to see your design 3D printed and raced. So a bit about SRIL Robotics Innovation Lab. We're an organization dedicated to empowering youth innovators through STEM. We host events like these every summer for hundreds of youth, and our partners include City of Surrey, Surrey Schools, UBC, Center for Community Engaged Learning, as well as SFU. We're extremely grateful to UBC Center for Community Engaged Learning for awarding us with the Connect to Community grant. Their support makes it possible for us to host events like these. Now, I would like to encourage you to click on the emoji for applause as we give a hand to the entire SRIL team for putting this project together. And as well, let's all give a hand for you guys, the participants, for joining us today and making this event possible. At this point, if you would like to, please turn on your video and we can take a screenshot together.
All right, let's begin. Let's start with a quick overview. Now, you're probably firstly wondering, what is a gravity car and what have I signed myself up into? Maybe you've taken a look online, maybe you've searched it up a little bit. Well, if you want to take a guess, now's your time to do so. I keep misclicking, I'm not used to this. Don't worry about it. Now, you might find that you have a button. If you go onto your control bar, you might find something called Annotate. Can anyone locate this button? Yes, you have found Annotate. Now, we'll give you a little bit of time. We would like you to answer the question, what is a gravity car? We'll give you guys about another minute and we will see what you have written. Okie dokie, let's take a look at what you have written. First of all, annotation off. And let's see what results are here. Car go vroom. Yes, the car will go vroom. I think that says race. Yes, there will be a race. And yes, the cars are going to get very quick. Maybe not as chaotic as you suggest, but they will be quick. I see a lot of people mentioning gravity. That is right. It's called a gravity car. It's powered by gravity. And as we can see, a lot of people have the idea of having weight, size, and a bit of chunkiness in their designs. This is about on the lines of what a gravity car is. So fantastic overview. And for those who said, I'm not sure, I don't really know, well, we've got a slide to get you up to speed on this topic. So, A little overview into what a gravity car is. It is also known as Pinewood Derbies and was invented by a man named Don Murphy in 1953. At the time, there were these things called soapbox derby racing, where you would build a car, a small model, well, not small model, but almost like a go-kart, and you would race it down a hill, and the fastest car to the bottom wins. But as you can imagine, building a go-kart in your own garage isn't very easy. So, Mr. Don Murphy made it smaller and named it Soapbox Derby Racing. Well, I can't read. He named it Pinewood Derby Racing. Now, this is because these are small model cars. They're not very big, and they're carved out a small piece of pine. Now, these cars would be raced down a ramp, and so began the idea of gravity cars. Now, of course, our cars will not be made of pine wood, hence the name gravity car. So, you might be wondering, what will I be doing here? I get that there's going to be a car, there's going to be a lot of stuff here and there, but what you will primarily be learning here is engineering design, basic CAD, the fundamentals of 3D printing. If you're in a team, teamwork. And just be aware that there are only 20 team slots in total. But let's just backtrack a little bit. So, you see you'll be learning engineering design, CAD, 3D printing. Wonderful for all you tinkerers out there. Have something to design? Got an idea in your head? After these workshops, after the challenge, you might have some abilities to create things of your own. But as a tutorial, we'll be still running the challenge first and foremost. All right, so now you're probably wondering, this is probably too good to be true. We're building gravity cars, so what's it gonna cost me? Well, let's begin. Parts list. There is no cost. It is too good to be true. Well, except maybe for your time. You're probably going to commit a few hours here and there tinkering in and out with your designs. Thanks to the generous contributions of the Connect to Community grant from UBC, they have been able to provide us with the materials, the printers, and the technology to empower you guys to design at home, and we will build it for you. Woo! So let's get to the challenge then. So how does the scoring work, you might be wondering? Well, there's a maximum point count of 35. There are two categories of points, speed and style. Now, admittedly, the fastest car might be a stick, just a small, thin, narrow bar. It doesn't look very cool when we're watching a whole bunch of sticks roll down a ramp. So we encourage you to get creative. And so this design style category gives you that opportunity. But we'll get into that in a little bit. So let's go look at the first point of scoring. Speed. Car go brr, vroom, just like you guys said at the start. Now, that's right. The fastest cars down the ramp. The first car down the ramp, well, the fastest car down the ramp will get 15 points. The second car, 14 points. The third car, 13 points. And so on. However, the last 10 cars will all get 5 points. But remember, the faster you go, you could get more points. The second category is design style. This is awarded for unique styling and attention to detail. Make it look fancy, make it look unique, give it your personal touch. Let's see what you guys are capable of. The points will be awarded by 3 segments. 5 from the SRIL team, 5 by guest judges from faculties and industry professionals, and 10 points will be awarded by yourselves, the participants and viewers of the final live stream. So if you've got friends, family, encourage them to come along and join us for the voting and the awarding process of this challenge. Okay, so we know how we're going to get points. Now, what about my car? I'm going to be building a car, so I might as well know what it is. So let's take a look. Here are the rules and restrictions of your car as per the design guidelines. Your car dimensions are a maximum of 100 millimeters long, 50 millimeters wide, and 40 millimeters tall. And if you want this in centimeters, 10 centimeters by 5 centimeters by 4 centimeters. Now this car will be built entirely in CAD. And the file that you will submit to us on August 14th, 2021 is called a .stl file. This will be used to 3D print your car. We'll get into more details on that in a little bit. Your car must have your team name. You wouldn't be as unique as you want. And if you want, well, you can add a number to your car. We might give you the team number that you will be assigned, or you might be able to put your own number on there. It's all down to the creativity. There must be two 2.2 millimeter holes through the entire car for axles, because if you have no axles, you don't have wheels. And instead of a car, you have a slab. And a slab doesn't go anywhere. Ask the Egyptians. Now, provided wheels that we will put onto your cars will have a diameter of 30 millimeters and a thickness of 9 millimeters. Why is this important? Someone's going to build a car that's really small, and then the wheels don't fit. So just remember, your wheel is 30 millimeters and 9 millimeters thick. Don't forget that, or else they probably won't fit. Okay, now we have our car. Now, how are we going to race? Well, you'll be racing down a track. This track will be 6 meters long and 1 meter high. As per the sketch below, this is the design of the track. Of course, you might see holes in it. There will be no holes in the final track. I assure you there will be no traps. There will be no obstacles. It's a straight line. Excellent. Well, now that we've gone over a few of our event details, it's time to get into the interesting stuff, for which I will hand it down to Daniel, our technology lead.
Yes, thanks, Clay. All right, so yep, I'll be going over the CAD section of this workshop. So shall I share the screen then? All right, hopefully you can see my screen. Yeah, so CAD. Does anyone know what CAD stands for? I would like to see your answers in the chat, so please use the chat feature in Zoom. What do you think CAD stands for, and what do you think CAD is used for? Let's hear your answers. I see a lot of people are saying computer-aided design, computer-assisted design. Computer-aided design, yeah, a lot of computer-aided design. Well, that's good to hear. That is correct. It is computer-aided design. And what do you guys think CAD is used for then? All right, 3D printing, to design models for 3D printing, a lot of modeling, a lot of 3D modeling, 3D rendering, to build
Yes,
stuff.
sorry to pop in for a little bit. If you
Oh, yeah?
do have a question, we recommend that you write it down. We will be having a question section at the end for you to ask us questions. I saw a great question in the chat earlier. I will definitely note it down and I will answer it at the end of the presentation. So I would kindly ask you to please hang on to your questions for the end.
Mm-hmm. Modeling and rendering 3D objects, simulation, architecture, very cool. Yeah, that is, you guys got it. That is basically what CAD is. So that's good to hear from you guys. All right, let's go on to the next slide then. So CAD is computer-aided design. You could also call it computer-assisted design, computer-aided drafting, Those are also alternate words, but we're going to stick with computer-aided design. So CAD is used by engineers, designers, tinkerers, makers, hobbyists to create 3D models and to run simulations, right? So its main use is for creating a detailed and accurate model of something that you want to fabricate. And you can also assemble multiple parts together in what's called an assembly that moves in the way that it would in real life. So for example, if you look at the picture on the right, you see a hinge that is broken down into 3 parts, right? You see the top part of the hinge, the top joint, you see the bottom part of the hinge, the bottom joint, and you see a shaft that will go through the holes of the hinge. And basically, you can use the advanced features of CAD software to limit the movement of this assembly so that it moves in the way that you would expect in real life, right? Because in real life, you wouldn't have like the joints clipping into each other or phasing through each other, right? So that's one of the big things CAD is used for. Secondly, another use for CAD, this isn't as much of a primary usage, but another way you can use CAD is for running simulations to predict the behavior of your model under certain conditions. So in the next slide here, you can see there is a vehicle, right? And it is a screenshot of a flow simulation, a wind tunnel flow simulation. And the lines you see are streamlines that are near the car. And that gives you information on, for example, the car's aerodynamic properties, right? All right, so now let's go over some software that you can use for designing your cars. The first one, it's a big one. It's called Solidworks. Some of you may have heard of it. It is one of the most widely used CAD softwares in the industry, and it's often found in higher level education. So if you're a university student, you might find that your university offers you a SolidWorks license. And that's because SolidWorks is an industry leader, and you can find it in education and in the industry. This one was originally launched in 1995, so it is a pretty well-established piece of software. But however, it is very costly and generally not an option for single users. So if you do have a university license, that's great. But for single users, it is very costly. So moving on to the next example of CAD software, we have Autodesk Fusion 360. Autodesk Fusion 360 is a more modern CAD software, and it is geared more for the modern maker, right? A maker or a hobbyist enthusiast. And it was released in 2013, and it comes free with license, right? So I expect most of us, if not all of us, are students, right? In high school, maybe, or in university. You can apply for a student license with Autodesk, and you will get a free student license of Fusion 360. Okay, the next example is Autodesk Inventor. And this one is, it's also by Autodesk, but it's a little bit more established. So it is more similar to SolidWorks, and it works well with AutoCAD. And some of you might have heard of AutoCAD. It is a widely used 2D drafting software. So it works well with that, and it was first released in 1999. And like the other Autodesk softwares, it does come with a free license as well if you're a student. And this one is the software that I will be going over in more detail in the next workshop. So if you're interested in learning more intermediate or advanced CAD modeling techniques, Autodesk Inventor is the one that we'll be using in the next workshop. All right, lastly, we have Tinkercad. Tinkercad is a simple online platform that's suitable for beginners and users of all ages. It has all the basic modeling functionality. It's free for all users, and Tinkercad is the platform that we're going to show you more of today in this workshop. All right. So the next section, I'll be handing it back over to Clay, and he'll be doing a quick demonstration of how to use Tinkercad.
All right, thank you, Daniel. All right, I heard that some of you have already used Tinkercad. That is wonderful, but some of us might be a little bit new to this. So let's take a quick look into Tinkercad. So after you make your account, you will need an account, you'll get to this page. This is known as your dashboard. Normally you would have a ton of designs here. However, when you first make your account, you will have nothing, as you see on my screen. So let's create a new design. What we can do is click this button. However, before I go into creating a new design, I'd also like to show you one quick feature before we jump too far into it. There is a neat little button on the top right called Learn. If you click this, you will find a whole bunch of tutorials. So if you ever get lost here, or you forgot how to do something, feel free to take a look in the How to Tinker category, the Learn button of Tinkercad. Now, without further ado, we shall be designing our simple tutorial car. So entering, I click Create a New Design. This is the basics of CAD. You have a big blue rectangle. This is known as your work plane. Everything you do will be put onto this table. It's an imaginary table, only it's very thin and not 3D. But we'll get to that in a little bit. Now, I also have this cube that says top and front. I can use this to change how I look at my design. As you can see, I'm rotating around the work plane and changing how I look into things. For now, let's go to the top. There we go. Double click the top and you will end up at the top. Now, I'm tired of my two-dimensional blue rectangle. I want to make something in 3D. Well, I've got these basic shapes. So, as we start our car, let's put in a rectangle or a square. You see, a square is a type of rectangle, but a rectangle is not a square. So, we've got a box, but this doesn't look like a car yet. No, it's just a cube. So I'm going to go stretch. And I'm going to go stretch. By clicking on these black squares, I can change the length of my design. This is a process called extrusion. And that is about the size of a car. This is as big as you can make your car. Okie dokie. So we've got a rectangle, but I need axles. I need a roof. So I will make some holes for axles. This shape, as you all know, is a cylinder. We have two options. We can make it a solid, just like our rectangle, or if we want to make a hole, we're going to select the button that says hole. By clicking one of these curvy arrows, we can rotate the object. If you want it to snap to a certain angle, you can press Shift and it'll automatically rotate to that angle. It'll snap. And now we have a cylinder. But wait, it's the wrong size. Now the way we resize this is simply by clicking it. We can actually open these length and size indicators. We can actually type in the diameter or the length that we require. In this case, it's 2.2. Same thing with the top. We can find the size for the top, change it to 2.2, and we have a small cylinder to cut a hole in our car. So moving it around, we can yoink. Oops. I already broke it. Nice. CAD isn't fast. Trust me, you're gonna want a little bit of patience doing this stuff. So we're just going to carefully place it approximately where we want our axle. Just to save time, I'm actually just going to copy paste it using the simple key, Control-C and Control-V on your keyboard. For Apple users, I'm not entirely sure how to do this on an Apple device, but you'll figure that out. All right, so we've got our axles, or some axles, put into place. But you're going to be wondering, wait, I see cylinders, I don't see any holes. Well, to make your holes, simply select your entire shape and group all the pieces together. What do we have now? We have a rectangle with some holes through it. Well, that's all fine and dandy. You've got a rectangular car. But what if I don't want my car to be a rectangle? We're looking for something fancy. Well, let's remove this using the trash button. And let's try designing something completely different. We're going to go to the top. And what is this? There's an option for scribble. This will let you draw your own design. So let's draw a simple car. Boop, 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 boop. And something like this. Now, something you have to remember is you have to fill it in. Anything that you want solid, it'll take a little bit of time, and you're just going to slowly fill in the car with color. You're just watching me. I know it's boring, but you'll get to do this on your own, and it'll be a lot more fun. Almost done. A little bit farther. Voila! We've got kind of something that looks like a car. Okie dokie. Now all we have to do is click done, and we've got our shape. But oh no, it's sideways. The car just needs to be rolled over. And ta-da, we have a car. Of course, there are no holes for wheels or axles. I didn't keep that in mind. But now we have a car that kind of looks like a car. Now, you're probably wondering, wait, you mentioned we need to put a team name or a team number on the car. Well, you've got a text generator. Simply set to hole, write your text. Cool boy. Let's make it that. Ooh, we've got 3D letters. We're just going to shrink it down to the size of the car. Turn it 90 degrees again. Oops, come on. There we go. And I'm just going to put it into the car. Ta-da! I think I'm going to put it in here. I think that looks cool. Oh, uh-oh. And I broke it. Ah, the wonders of CAD. Sometimes your CAD model will break, sometimes it won't. Hopefully it won't. But just like we did earlier, select everything, group together, and we've written cool boy on our car. So I hope that is the very, very basics of Tinkercad. I don't want my car named the Exquisite Kieran Gogo, so I'm just going to name it Car. And there we go. We've designed our first car. And as such, it looks beautiful. So now that we figured out how to do some basics in Tinkercad, and you are armed with the greatest knowledge of CAD in the world, we can move on to the next phase of construction. How are we going to 3D print this? And for that, I'll hand it back to Daniel.
All right, thanks, Clay. That was a wonderful demo. Radio then. Yeah. All right. So 3D printing. So once you designed your gravity car body, we're gonna want to 3D print it, right? So I'm gonna go over 3D printing is.
Whoa, wait. I forgot something. 3D
Oh.
printing? We don't know how to make our car into a .stl file. Oh no!
Oh no.
Back to Tinkercad.
Yeah, okay, Clay, maybe you should let us know then, perhaps.
Yeah. Okay, so we've got the cool boy, our amazing cower. So let's print it. It's really easy. We got this button called export. Click. And now it tells us to download the design. Don't worry, there is no virus. It's just the car file. Simply click .stl. It'll say preparing for export, and you will download it. You probably won't be able to see that I've downloaded it, but just trust me, it's going to appear in your downloads folder. All right, now that we have our STL file, I'm going to send it over to Daniel for printing. Bleep, bloop.
Radio then, okay. Yeah, okay, that is important then. Putting it into an STL file. All right, yeah, okay, so 3D printing. So once again, please use the chat feature of Zoom. I want to hear from everyone. Has anyone used a 3D printer, or has anyone seen a 3D printer in action before? Or perhaps at your school, right? Or a public library or a local makerspace? Just let me know if you have ever used or seen a 3D printer in action. Yeah, oh, yeah, a lot of people are saying yes, and that's great to hear. So can you guys tell me where you've seen it? I'm curious to know. Okay, Richmond Public Library, yeah. School library, school, at my friend's house, so that's good. So some of you have 3D printers of yourselves or your friends have them. And it's good to hear that a lot of schools have them too. Yeah, that's great. All right, yeah, so some of you, so almost all of you guys, or all of you guys know kind of the gist of what a 3D printer is and how it works, right? So I'm going to explain a little bit about it now. So what is FDM? FDM is fused deposition modeling, and it is just one of the many 3D printer technologies. FDM is one of them. You have SLM, you have SLS, right? Those use combination of light and UV light and instead of heat to create your 3D prints. But what we're gonna focus on for this workshop is the most common type of 3D printing technology. And this is probably the kind of 3D printers that you have seen at your schools or at your local public libraries. And this is the FDM printer, right? The fused deposition modeling printer. And how FDM printers work, they work by using heat to fuse layers of material together, right? So the material is fed into an extruder, which has a nozzle in it, and it melts it. It melts it through the nozzle onto the build plate, and it prints it up layer by layer. And the material often used in FDM printers are thermoplastics, right? So what are thermoplastics? Thermoplastics are plastics that are engineered so that they react at certain heat levels. So for example, you have a common thermoplastic called PLA, which is polylactic acid. This is a very common type of material that you would use in a 3D printer, and it melts at around 200 degrees Celsius. So what an FDM printer does is when you feed the filament, the material, into the nozzle, heat it up to around 200 degrees Celsius to melt it, and then as it cools, as it prints layer by layer, it will become solid, and you will have your solid objects, right? And you have other common thermoplastics like ABS and PETG. Perhaps you have also heard of that. So the next slide here, we have two time lapses of FDM 3D printers in action, right? So on the left, you have a 3D printer printing this hedge sort of shape, and on the right, you have it printing this sort of 3D polygon. And in both ones, you can see that it is printing up layer by layer, right? It is going around, it is extruding that filament through, and it is building up layer by layer. And these time lapses are sped up many times, so it looks pretty fast, but 3D printing is a very methodical and slow process, right? Each layer is about less than half a millimeter thick. So printing something like this, it does take quite a while. It prints it up layer by layer at half a millimeter thick every single. All right. So you guys are probably interested in knowing how to submit your prints to us and how to get it on the racetrack, right? So let's go over the steps then. Step number one, you're gonna have to register yourself or your team for a spot in the race. We only have 20 spots, so we do encourage you to dazzle us with your design plan when you're filling out the registration form. Number two, step two is to design your gravity car using CAD software of your choice. So today we went over Tinkercad. So hopefully if you didn't already have some experience with Tinkercad, you learned a little bit about it today, and you can, after this workshop, find out for yourself. And in the next workshop, next Saturday, I will be going over Autodesk Inventor and some more advanced techniques with building your car in Autodesk Inventor. So for the design of the gravity car, you only need to design the main body with the holes where the axles will go, right? Because once you send the file to us and we print it, we will assemble your car with the axle and with wheels for you, right? All right, step number three is to submit your designs to us by August 14. So that's the deadline. You may start as soon as you want, but the deadline is August 14. And of course, step four is we will print your designs once we receive them. We will assemble them with all the same axles and all the same wheels in time for the race. And those are the 4 steps for getting your submission in to us for the race. All right, now the race. I'm going to hand it back to Clay for the details on the race.
Okay, the race. We're down to starting to get to the end now. Boop. Note to self, prep slide before changing documents. There it is. Present. Okay, we're at the race. Let's take a look at what this race entails. It'll take place on August 28th, 2021 through a live stream, as you are probably watching right now. Unless you are watching after this recording is concluded, then it's not so live stream. Now, the cars will be raced down a track and they will be timed. The way we know a car is faster is it will have a faster time down the ramp. And in the time of voting for the design category, we will have a poll released during the event so the attendees may vote on their favorite designs. Now that we know how things are going to work, let's quickly review what we have talked about. So, scoring, speed is out of 15 points. Design creativity is out of 20 points. Viewers of the event will be able to vote on their favorite designs. And the maximum points for any team is 35 points. The track is 6 meters long and 1 meter high. The cars will be timed from the start to the finish. The car specifications. Your car's maximum size is 10 centimeters by 5 centimeters by 4 centimeters. Those are the length, width, and height parameters. The files must be submitted as a .stl by August 14th, 2021. Your team name and your creative number, or the team number assigned to you from SRIL, must be placed on the car. You must have two 2.2 millimeter holes for axles. Otherwise, we will put your block on the track and it will not roll. Your time will be, I don't know, infinite, I guess. It never reaches the finish. Not sure how that works, but okay. And just a reminder, it's a bit missing here, but your wheels will be 3 centimeters in diameter with a thickness of 9 millimeters. So just under a centimeter thick. That's the only piece of information that we forgot to add to this slide. Okay, CAD software. We recommend the use of Tinkercad for beginners. However, if you wish to use a more complicated program, please feel free to do so. Now, CAD designs submitted to SRIL are to be sent to us again by August 14th, 2021. Do not miss this date. Otherwise, we will not be able to print your car in time. Now, the 3D printing and assembly. Don't worry about it. That's on us. We'll put your car together and everything will be amazing. There's no cost to you at all. Now remember, the race is on August 28th. You've seen this number multiple times, so it's probably burned into your head by now. Don't forget it. Bring your friends and family, vote on your favorite designs, and race to win. And just before we conclude, there are prizes for the race. There will be gift card prizes. The amounts will be specified very soon, but we will assure you it's 100% worth it. I mean, it's free. You get stuff for free. It doesn't get better than that. Okay, now's the moment you've probably all be waiting for. Registration time. So you'll have a few days to register, about a week to register, I would presume. And we have the registration form, which should appear in the chat right about now. I'm assuming it's in the chat. That is the registration form. Remember, take your time to fill in these blanks. We recommend you fill this in after this presentation, since in the case that we have more registrants than team slots, we'll be taking your answers into consideration. However, don't be discouraged if you don't get selected. You may still feel free to design your own car. Even though it might not race, we will still post all the CAD designs on our website so everyone may see your amazing creativity. And just a reminder for our future workshops, Daniel will be hosting the Intermediate and Advanced CAD and 3D Printing workshop next week on July 24th at 2:00 p.m. And if you're curious about the science behind these gravity cars, what these concepts do on a full-scale car, and looking into the possibilities of future endeavors from your learning, feel free to join us on August 31st for the Science of Gravity Cars workshop. All right, that brings us to the end of the presentation. I believe some of you will probably have some questions. So without further ado, we have some time to answer your questions. It's your time to take the spotlight. You may feel free to unmute your mic if you prefer to talk to us, or you can send something in the chat.
All right, Clay, we have a question. Can I design my car into a ball? Is that a valid design?
A ball. Well, if you can figure out how to put your axles on it without offsetting the weight, sure. Now, I'd be surprised if you figure out how to get a ball into your size limit. If your car exceeds your size limit, you will not be, it will not be printed and it will not be raced. Also, to finish up with that question about the ball, as much as I love the creativity behind this, you're going to have to be very creative. I'd love to see it, but it might roll off the track. So good luck with that. I'm not going to say no, but I wish you the best of luck. Now, do family members have to use different Zoom accounts? I'm not entirely sure how this works. Perhaps so.
It would be great if you can, because we'll be counting participants in our meetings to report back to our UBC sponsor. So they'll be looking for that, and we would prefer if you use different accounts for family members. All right, next question. Is there a maximum weight allowed for derby pine cars?
For Pinewood Derbies, I'm not entirely sure about the weight requirements or the weight minimums or maximums. However, for our challenge, we don't have a maximum weight, nor do we have a minimum one. But I doubt you're going to be able to get too much weight out of plastic. All the cars will be printed with 10 or 15% infill. So the weights will be about the same. The weight reduction comes from size. So you can try to maximize your weight, but you're going to have to be resourceful with what you have in your design. I bet someone's going to put a solid block in their car to make it heavier. But if you do that, by all means, go ahead.
All right, next question. What happens if your car exceeds the size limit?
Yes, I think I went over this one. Your car will not race. We will be checking all of your car designs that are submitted before the deadline, of course. And if it's too big, we'll let you know. We'll send you an email back and tell you, oh, you're over the size limit. So just keep that in mind as you design your car. A car that is bigger than our size limits is a no-go, unfortunately.
All right, thank you. And then next question is, can I design using some other software like Blender, 3ds Max, or am I allowed to use other software?
Absolutely, you are allowed to use other softwares. However, we would prefer if you used a CAD software. I'm familiar with Blender as more of a 3D graphics design software. So it's a lot more powerful in 3D modeling and whatnot, but not exactly for the engineering purposes that we're going for. Well, I would suggest that you take a look at Tinkercad. I'm not going to say no to creativity, but having something like Blender where you can contour curves using blocks and shapes that you can bend is kind of outside of the fairness of the competition. So I'd prefer if you used a CAD software as opposed to a graphics design software. But I'm not going to say anything. I'll let you decide whether it's in the spirit of the competition. In my opinion, though, I would consider it a little bit on the cheating side.
Great answer. Will I have to make the hole for the axle larger, since a 3D printer might make the hole a bit too tight?
We've already given the printers tolerances, so the shafts are actually 2 millimeters in diameter. So we added a bit about 0.2 millimeters extra to give it that clearance. So it's already being calculated. That's why 2.2 millimeters is such a strange, unround number, because that's for the tolerances. So 2.2 millimeters should be good, but if you feel like you want to add a little bit more tolerance, you can feel free to do so.
Will all cars be printed with the same materials?
Absolutely. I'm not sure about the color, but they will all be the same PLA material.
Oh yeah, they will be the same material with the same fill, so the same density. So yeah, right? And then someone asked, what happened to the 2.2 millimeter holes in your cool boy car, Clay?
We don't talk about that. I completely forgot about 2 millimeters holes, but you already know how to put those on your car, so you don't need to see it on the cool boy car. Besides, the cool boy car hovers now. It's too cool for wheels.
All right, and what will the wheel be made of?
The wheels will be made of some sort of generic black plastic purchased off of Amazon. The shafts and the rods for axles will be made of metal, or I don't really know, metal shafts, metal pipe thingies, also found on Amazon. So they're just generic off-the-shelf parts. Don't worry about it.
How do you put weight in designs?
That's for you to figure out. We don't have weights at SRIL. We don't know what to put in. You're gonna probably want to get creative with that.
Oh, Claire, I thought we were just printing the design and we have our specified density. So whatever volume you use, that'll be your weight because everyone will be printed using the same density.
Oh yeah, that's exactly the point. So yes, they'll all be the same densities, but there are actually ways to get around that. And that's what I'm hinting here. While we cannot add more parts to your car other than plastic, you can kind of do some weird trickery with your CAD. So I'm not going to tell you that because it's going to make our printing time exponentially longer, but I'm just putting it out there. It's possible to do some crazy.
Yep. And I just want to say that it's also kind of an optimization problem because the more volume you have with your car, so like the more length, width, and height you have with your car, you're going to have more mass, right? But you might not want to have that extra mass because maybe you want to cut down on the contours a bit, make it more aerodynamic, right? So it's up to you, right? It's up to you to design. Do you want a more maybe thin aerodynamic car, or maybe you want more mass, but then the car will have to be bigger? Do you know what I mean? Or are you just trying to go for a wacky design and just get all those design points, right? So it's up to you to be creative and up to you to make a design that you want.
Great answer. And next, can I just design a really big ball? So
Ooh,
that
it's
has been
another
answered.
really big ball question.
Yes.
I mean, you can try, but remember, you've got to follow those size requirements, follow those hole requirements. And if you have holes, we're putting axles and wheels on them. So good luck with keeping everything balanced and making it roll. I'd love to see it happen, but as far as I'm concerned, it's just not possible. But if you want to try it, go ahead.
All right, are we doing 10% or 15% filling?
Daniel?
Oh, right. We're looking at 10% right now. But it's not set in stone yet because we want to get your designs and we want to make sure that your designs will hold up structurally, right? So we can't make a good decision until we get all of your designs in, but just know that it will be fair across the board. So if we end up with doing 10%, then it'll be 10% across the board. If we do 15%, it'll be 15% across the board. So it'll be fair for everyone.
Yes, excellent answer, Daniel.
Yes. And can we add more wheel axles?
Unfortunately, no, we only have enough portions for 4 wheels and 2 axles per car. So no, you cannot add more wheel axles in your design. However, if you want to create a CAD design that has more wheels and axles just to be posted on the website, you can feel free to do so. However, your competition design that will be racing may not have more than 4 wheels and 2 axles.
Great.
I hope that answers the question.
And then next question, how do we submit our designs to SRIL?
We will release a poll, or not a poll, but a Google Forms where you're able to upload your file and provide us with your design. So what you'll end up with, I believe this will be given next week in Daniel's email. You'll have a little bit of time to figure out your designs prior to then. And we'll probably send it out within the next week on instructions how to send your design to SRIL. It might be coming next week or a little bit later, depending on some logistics that have to go through. But we will confidently say we will let you all know how you will send your designs to us.
Yep. And then
I think just to add on to that, I believe most likely we'll have a drop link on our website, similar to how you registered for our event. There'll most likely be a link there in the future so that you can submit your designs.
And how do we scale the model from CAD to real life?
You're going to have to be a little bit more specific with this question, Matthew.
You're asking for the dimensions. So for this question, the answer would be the dimension you put into CAD, that is the real life dimension. Because when you save it as STL, that will be the dimension that we get, and that will be the dimension we print. So make sure you specify the dimension you want us to print.
Yep. So that's actually how CAD works, is that whatever you put into CAD will come out as the sizes that you put into CAD, plus or minus maybe 1/100th of a millimeter. Now, if you're talking about making it gigantic full scale, we're not doing that. We're not building a full scale car.
Yeah, and I just want to clarify one thing with the maximum size requirement. So we have a maximum length, width, and height, and those and our requirement is that you cannot exceed individually the length, the width, or the height. So what we're not saying is that you can say you save a bit on the width and you can like compensate by exceeding the height a bit more. We're not saying any of that. We're saying that you simply can't go over the length that we say, the width that we say, and the height that we say. All right,
well, I tie it on to Daniel. Just imagine you have a rectangular box that's 10 centimeters long, 5 centimeters wide, and 4 centimeters tall. If your car fits inside of that box, you're good to go. If your car sticks out of the box on any side, it's a no-go.
All right. And then can we design our own wheels for aesthetic purposes?
You can design your own wheels for aesthetic purposes. However, during the race, to make everything fair, we'll be equipping your car with the wheels that we have sourced. All the cars will be on the same wheels, but if you want to design your own wheels for your aesthetics, go ahead.
Is there a minimum height required?
There is no minimum weight. I can't speak today, but there is no minimum height required. Your car can be 0 millimeters high. I'm not sure how you're going to do that, but there is no minimum height. Good luck with that.
Well, you would have to fit the axle probably, but we'll see. All right, I think this is a comment. Can I design a mini Tesla? That would be cool because we will have a presentation from a Tesla speaker in August. So please show up for that presentation. Okay, for teams,
sorry, Sophie, we are running out of time, so I'm just going to do a quick speed run of whatever remains. Okay, for teams, if only 20 are entered, how do you know we are registered as it's just yourself? During the team registration form, when you open it, you will be able to see the people you will be able to enter yourself and 2 teammates. So one person will fill out the form for the other 2 friends, assuming that you all know each other and have talked about it already. So that's how it's going to work. There will be slots to put in yourself, the team leader, and the 2 teammates. And that's how we know how many people are in the team. Hopefully that answers the question. I think the person with the hole is asking if they are allowed to have no. You have to have holes in your ball. You must have axle holes in your ball. Oh, this was from internal SRIL. So they just wanted me to clarify for the people who wanted to build balls, you have to have axle holes. You cannot just have a ball. Daniel says, you can't change the weight of the car, so you can change the center of mass. Absolutely. You can shift that center of mass anywhere you want. How many team members? 3 maximum. You can have a maximum of 3 members per team. They are a straight axle. So it's not nails, it's just a rod connected to 2 wheels sandwiched in the middle. So wheel, axle, wheel. Okay, excellent. Daniel, that's not a question. Excellent. What is the ramp's incline?
Answer that in the chat. It would be arctan 1/6.
It's going to be about 26 degrees if we make our calculations correct, but it will not be super steep. About 26 degrees is about what we're thinking of. Can I make the car super tall? Super tall as long as it fits within that 4-centimeter height. 4 centimeters is super tall. That's as high as you can go. We don't have to design holes or wheels. The holes you will have to cut into your design. We need holes that go all the way through the car, but you do not have to design the wheels. The wheels will be provided. Registration form needs a design plan. So you do not have to finish your design before registration, but we want to see how you plan to accomplish your goals. So if you have, for instance, you're starting to build something. How do I know that I'm going to finish it on time? What is my calendar? Do I have a plan? Yeah, that's what we mean by design plan. Like a schedule. Will you put the wheels in the ball? No, we will not put the wheels in the ball. We will put them on the outside, just like every single other car. Solo team, yes, solo teams are okay. Ramp, that's, yeah, okay. The ball guy. Okay. Can your parents be your team? We don't recommend doing so because that would offset the experience gap. That's like asking a professional engineer to construct your car for you. It's a little bit cheating, but you can always definitely, we do encourage parent and child working together, but we just don't want them to do your entire car for you, is what we're saying here.
Yeah, let's we can say
They're answered. Just saying.
you can, yes, like as far as, you know, like just go around the house asking your parents, oh, you know, mom, can you help me, can you give me some your opinions on this, right? You can ask, but in terms of actually putting the names on the form, we said we would only allow people to register for this race if they came to the first workshop. So ideally we would only want to see your fellow high school students or fellow students who are here at this workshop today, the team members on the race team. But nonetheless, we do encourage you to, you know, you can ask your parents if you want. Just maybe not officially as part.
All right. What is the distance between the left wheel and the right wheel? That is whatever your design wants it to be. The maximum distance between the right wheel and left wheel is 50 millimeters or 5 centimeters. That is the maximum distance. There is no minimum distance. So whatever you think your design needs, you can feel free to do so. Why can only 20 teams enter? You see, it's free for you guys, but we also have limited parts. We can't buy too many things as of now. So we only have enough parts to sustain 20 teams. So for this year, we're limited to 20 teams. Maybe in future years we can expand, but for now, 20 teams is the maximum because we have limited resources and it takes a long time to 3D print things. So we have limited printing capacity. You are not, in terms of the next question now, are we guaranteed at least 10 points for speed? You are guaranteed at least 5 points for speed. The last 10 teams will get 5 points. Design points are not guaranteed.
Okay, next question. Can you send us the slideshow for future references?
Yes, we will be able to do that. I believe so. Sophie, do you have any sites on this?
I think, of course, we can. We can ask Irene and then she will, yeah.
All right, we will definitely release this slideshow for your future references.
Okay, and then Owen is asking, is this for only high school and up? Nope, this is for all youth. So you're welcome to register.
Albeit, I do recommend that this is primarily for high school. So if you are in high school, you will get priority. Since university students will probably unbalance everything.
They said they are not in high school yet, so they are allowed.
Oh, if you're younger, that's fine.
All right, so for the racetrack, does 6 meters include the flat after the slope?
The 6 meters is the entire length of the track. So that is both the ramp part and the straight part.
All right, and the name, does the name have to be on the side of the car?
The name can be anywhere on the car, wherever you want to place it. Except the bottom. Your name will not be on the bottom of your car. We would like to see it displayed as you race.
Exactly.
Really quick, I've also got another question here. The next workshop is next Saturday at 2.
Yep.
Yes, that is right. That's 2 p.m. Pacific time. Okay.
And that is all for the questions for now.
I think that is all the questions. And what do you know? That is also all the time that we have today. So without further ado, we at SRIL would like to thank you all for showing up today. And we wish you the best on your endeavors. All righty. Without further ado, I think it is time to wrap up. Again, thank you all very much for coming, and we look forward to see you again next week, the week after, and at the challenge, and at the Tesla workers or the Tesla speakers workshop. And if any of you still want to have any extra questions, I will remain here for just a little bit afterwards to tie up any loose ends. All right, thanks everyone.